recognized. Okay, now how about BB? BB, not an accept state, so reject. So if it went this way and reads a B, dies. So it doesn't work. BA, BBA. BA, B dies. BA dies. BABB. B. No, can't. Right. So these are rejected. Okay. So there's a homework challenge. Try to figure out what the function is of this NFA. What is its language? Right? What all the strings W in the language, members of the language, what do they all have in common? So if you're describing the set of W, the set of strings recognized by this NFA, what's the description? The set of W such that W something something. Right? What is that description? So it'd be a homework. I don't know. It doesn't say. Well, not this far in the text. So have a look. All right. Okay. So next big topic. You remember earlier with DFAs, we started talking about DFAs in a rather informal way by using state diagrams, state transition diagrams. Okay, and then we realised there are lots of cases where you just can't use a state diagram. It doesn't work. Maybe too many states or some parameters not fixed, so you don't know how many states. So you're left then, the only possibility is a formal definition of your DFA. The five tuple. The capital Q, capital sigma, the delta transition function, the Q naught, the start state, and capital F, the set of accept states. Okay, that was the formal definition, the five tuple. Well, we've been, for examples of NFAs, rather informally, rather relatively simply, using state diagrams, right, like this, for example. This is our fourth example, using state diagrams. Well, we're going to do the same thing as we did with DFAs, namely, we are now going to create a formal definition for NFAs, right? So that's what this is all. So a formal definition of a non-deterministic finite automaton. Right? Now, it's pretty close. When you've studied the formal definition of an NFA, you'll see it's pretty close, fairly similar to what you're used to in the formal definition of a DFA. In other words, it's still a five tuple, with the same five members, the same five things in the list. So, in other words, set Q, set of states, an alphabet, capital sigma, a transition function. Now, I'm jumping ahead a little bit, but that's the essence of the difference between the DFA and an NFA. It's the heart of the difference, the core, the essential difference between those two. The DFA and the NFA is in the nature of the transition function, the delta, and we'll come on to that soon, but giving you a signal. And fourth thing, start state, it's pretty trivial, and the set of accept states. So pretty much the same. Okay, so now. So, as I was saying, so the main difference is the transition function. Now, you may remember in a DFA, deterministic. What's the transition function doing? If you sort of think in material terms, like imagine you are the DFA yourself. You're the automaton, and you're imagining how you would function. Well, the transition function in you, if you like, you're making a decision on what should the next state be, right? And that decision will depend on two things, two parameters. Depends on your current state and what input symbol you're currently reading, right? And depending on those two things, you make a decision what the next state should be. And that next state, given those two parameters, is determined. Right? There's no choice. There's just one and only one. Okay. So that's what this is saying. Now in a NFA, the transition function takes your current state, as with a DFA, and the input signal. So that's the same. So the two inputs are the same. Well, not quite. So it's either an input signal or the eta, right, the empty string. Right? You're starting to get fairly familiar now with the use of the eta. So, in a NFA, you have your current state. That's pretty much the same. But now your input symbol you need to augment a little bit with the eta. Okay. So, given an input signal or the eta, the empty string, then you produce not just one, well, you could, it depends, but usually a set of possible next states. Right? Now that's the essential difference between a DFA and an NFA. Right? The delta function can produce not just one next state, but a set of them, several, maybe 2, 3, 4, whatever. Okay. Right? Now, before we go any further, in this session, we need a little bit of new notation, because we'll need it in the actual formal definition. When we write out the 5 tuple for an NFA rather than DFA, we will need this new notation. So I need to introduce that to you a little. In fact, two things, two new notations. 2 items of notation. Now we've actually come across it before. Also in one of the questions we solved in the theorem, the problem solving session, and that was the concept of the power set. Can you remember the definition of what is a power set of a set? It's the set of all subsets of that set. So if you have a set Q, for any set Q, P of Q that's defined to be the set of all possible subsets, or in other words, this the power set of Q. Okay, so if you see this P of Q, that will signify, represent the power set of Q. Okay, so can you remember? If Q, the set, has big N elements, then the power set of Q will have 2 to the power N elements. Right? It's much bigger. So if N is large, 2 to the N is huge. Okay? So this P of Q is defined to be the power set of that set. Right? So that's one thing. So this P is a new notation. It just represents the power set of whatever the set is here in the parentheses. Okay, so P of Q is just saying the power set of the set Q. Now this is new notation. It's sigma. It's got something to do with an alphabet, right? But now you've got the little eta as a suffix lower here. So sort of sigma eta. Okay, and by definition, in 3 bars, it's defined to be your normal alphabet. Now that's a set, remember? Remember the alphabet is a set of allowed symbols in your input string. Okay? And we're used to that. Now it's a set, so we can union it with another set, and that's the empty string, eta. and the wiggly brackets means it's a set. So we can, so this now is sort of in a sense, sort of gets philosophical, an augmented set of the elements, the allowed symbols in your input string, right, sigma, unioned with the empty string, eta. Okay? So this is sort of augmented. You take the alphabet you're used to, right, that set, and you add one element to it, whatever that means, the empty string. Okay, so you just add eta to it. So you add eta to that, right? Now, equipped with this P of Q and this sigma eta, these two new items in our notation. Now we can write out the formal description. I don't know if you can see this line here, first line here, of the NFA's transition function. We'll use that P of Q, and we will use the sigma eta, those two items. We will use them in the definition, formal definition, of the transition function, the delta for the NFA. Okay, but that's next session.